Hi everyone, this is Dhanasekaran, Assistant Professor, Department of Electronics and Communication Engineering, KS Rangasamy College of Technology. And in this video, we're going to see about small scale fading in the subject name of mobile communication and networking. So these are the outlines. What is fading? Types of fading: small scale fading, multipath delay spread, Doppler spread, advantage and application. Introduction. Wireless communication. In wireless communication, the signals received over a communication channel have a variation in strength. This phenomenon caused by the various factors that affect the propagation of the radio waves. So in this topic, we going to see about fading, how the fading occur, and what are the types of fading. Everything we're going to see in this video. So what is fading? In wireless communication, the fading is a process in which the strength and quality of the radio signal fluctuate over the time and distance, and the fading is caused by the variety of factors, including multipath propagation, atmosphere condition, and the movement of object in the transmission path. So it can have a significant impact on the performance of wireless communication system, particularly those that operate in the high frequency band. So these are types of fading. So fading, we have two types. One is a small scale fading and large scale fading. In the small scale fading, again, the divided into two types. One is multipath split, and another one is Doppler spread. In the large scale fading, we have two types. One is pathless, and another one is shadowing. So coming to the small scale fading, small scale fading is a common wireless communication. It happens when the uh, signal signal is transmitted from transmitter to a receiver, and it's experience multiple signals paths due to the reflection, diffraction, and scattering from the object in the environment. Whereas in the large scale, fading occurs when the obstacle comes between a transmitter and receiver. This interference type cases a significant amount of signal strength reduction, and this because of EM wave is shadowed or blocked by the obstacle. And this is related to the fluctuation of signals over distance. Then it's called a large scale fading. So there's a one graph for the fading. So we can see the small scale fading and the large scale fading. So large scale fading represents a smooth dashed blue line, and shows the average received power decreasing with the distance because of path loss due to distance and shadowing from the large obstacles. And coming to the power variation occur large scale, large distance. So there are two modeling used for the large scale fading: on a long distance pathless model and the log normal shadowing model. In the small scale fading, so it is represented by the rapid fluctuation. That is a red curve. You can see in the graph around the average power. The power changes over a very short distance on the order of lambda by 2 shown in the figure. So here it's a case by small scale fading is case by multipath propagation, and can case a deep fads, rapid signal strength variation. And small scale fading, as I said, it happens when the signal is transmitted a transmitter to a receiver. It experiences a multiple paths due to the reflection, diffraction, and the scattering from the object in the environment. These signals path can cause interference and distortion to the signal, so resulting in fluctuations of the signal strength at the receiver. Small scale fading is called the small scale because the variation occur over a short distance such as a few centimeter due to the meters. The small scale fading can happen very quickly, sometimes in microseconds or less, in primarily caused by the multipath propagation of the signal. Overall, the small scale fading a common issue in wireless communication that affect the quality of received signal. However, with a proper mitigation technique, it is possible to maintain reliable communication even in the presence of small scale fading. So this is one of the type of small scale fading, the multipath delay spread. And the multipath delay spread, it's a type of small scale fading that occurs when the transmitted signal take multiple paths to reach receiver. The different components of the signal can arrive at the receiver at different times. So it causes interference and the rapid variation in the signal amplitude and phase. And multipath delay spread can cause intersimple interference where the symbols in the transmitted signal overlap with, and interface with each other, so that it leads to error in the received signal. The root mean square delay spread is measure of the dispersion of the signal or determines the frequency selective characteristics of the channel. So equalization techniques are used to compensate the time depression caused by the multipath delay spread, and the diversity techniques are used to combine the multiple signal path to mitigate the effects of padding. Coming to the Doppler spread is a type of small scale padding that occurs when relative motion between the transmitter and receiver. The relative motion causes a shift in frequency transmitted signal. It's known as a Doppler shift. So it cases different frequency components of the signal to arrive at the receiver with a different phases amplitude. So this results rapid variation in the signal amplitude and phase, which can cause fading errors in the received signal. So Doppler shift is the measure of the rate of the change of Doppler shift determines the time varying characteristics of the channel. A higher Doppler shift indicates the faster time variation in the channel, while a lower Doppler shift indicates the lower time variation. So Doppler shift is an important consideration in the design of wireless communication system, particularly for mobile application, where there is an often significant relative motion between the transmitter and the receiver. So diversity techniques are used to combine the multiple signal paths to mitigate effects of fading. And the adaptive modulation techniques are used to adjust the modulation scheme and data rate based on the channel configuration. So these are the advantage of small scale fading. Provides uh, time frequency and spatial diversity, and it improves link reliability and the data rate. So it enables spatial multiplexing. In facial multiplexing, independent fading paths allows a simultaneous transmission of multiple data streams, increases channel capacity without any additional bandwidth, and supports upstream scheduling. Coming to the applications of small scale fading, cellular systems, and it's used in the 2G, 3G, 4G, 5G, and MIMO, multiple input, multiple output, and massive MIMO systems, wireless LANs, and orthogonal frequency division multiplexing based wireless systems, and mobile and vehicular to vehicular communication. After watching this video, please go through these questions. Try to answer these questions. Thank you so much. Thank you for